serves millions of mobile users. So speak for speed of response. So I'll go over what the product is and why it is fast. So I think the cool thing about it is when Redis first came out, it is one of the early ones to come up with the idea of using in memory. Usually databases are on disks because disk is cheaper than memory. When you have a lot of data, it makes sense to keep it in the disk. But Redis took a different angle. It went for in memory. There are a few others, but Redis was one of the first few to do that. And it was also no SQL of key value type. Okay, it's open source. It's written in C. Like I was saying earlier, it's very compact, barely 20,000 lines, and it can handle a lot of data. There are single machine instances that handle 250 million different keys and values, all in a 3 megabyte footprint, which is like really efficient. And plus the data, of course, whatever you put in it. And I think what I found pretty amazing when I first read about it was it is single threaded. Usually when you're talking about tens of thousands of users using a database, you would think that it is going to scale with multiple threads and of course processes, but there's a single process, single thread, and it does it without locks. I think that solution was really cool. So why should you care about it? Apart from high performance, which is like hundreds of thousands of users per machine with thousands of connections that it can support, it has been demonstrated to work with like 50 million operations a second in 26 machine cluster in AWS. So I don't think any of the relational databases come to the order of 10 times equivalent to relational database in performance. It has very, so the idea with this is to be very simple, but efficient and performant. So it has very limited set of features, but whatever it has, it does it very well. And there are lots of use cases where you can apply those features. Since it's a key value, most of your lookup and write operations are big O1 complexity. And there are a few operations where you can scan through the data that's log n binary search complexity. So it's very quick in its response. So I've personally seen in our application it to be at least 10 times faster than Oracle for what we do. So it's a great as a cache for sure. In terms of its popularity, it's only 10 years old compared to Oracle or MySQL, which have been around for a long time. And it has climbed up in popularity to within the top 10 right after the other relational databases, and only exception being MongoDB, which is a document NoSQL database. Who uses it? There are lots of people that use it. I don't even have Ubers and the Netflix and Facebook's listed here. Stack Overflow, Twitter, they're all big users of Redis. As an example, Stack Overflow uses it as a cache whenever you have a users come in, the user session, the counts, the popular questions, they're all sitting on Redis. So if you notice, either it's volatile data that is accessed often, or there are computations, view count, which are computationally intensive on a database where it's going to scan. Those are all good candidates for summarizing with Redis. So it's I'll show you some of the features it has and how it makes it easy to do that. While it is in memory, it's not just in memory. You can take snapshots of database, so you can make it dump periodically without affecting the performance of the database at all. It does something pretty interesting. It has a background fork process which copies the memory and writes it to disk. So it doesn't affect the main database. And you can configure it to write every so often. You can also make it write after every operation. So every write or append, you can make it write to a log. And again, it does it as an asynchronous process in the background. So it's very, very efficient. Popular use cases, it's a cache. There are various flavors to it. It can be persistent or it can be with a time to live. Sorry. Time to live is when you want it to expire after some time. Like session is a good example of that. Or it can be least recently used or least frequently used, where you can use less memory because you don't want stale data or unused data to sit there. It can be used for counts and distributed logs. It can also be used for pub/sub, which is pretty interesting. You wouldn't think of database as a message broker, but it does function as a message broker too. And it can do streams, which is persistent messages. Online presence, user feeds, those are some of its uses. These are some of the you have a single cache like server or in-memory server, or you could have it with a slave where it is like a copied. So here, if the master goes down, it will switch to the slave. And you can also deploy as a cluster where the data is broken up into multiple servers. So it's a sharding solution. And this is where you can go to gigabytes or terabytes of data in memory. And at MasterCard, we use something like this, where you have a sharded main database with slaves as a backup. So we have a pretty big cluster that serves all the mobile customers. So let me move on to how it actually works. Okay, its elegance is in its simplicity. It doesn't have tons of features, but whatever it does, it's pretty capable, and it makes it very easy to use and efficient to use. So some of the data structures it supports, or rather the only data structures it supports, are a key value of a type, or a table, which is like a hash map, or linked lists, sets, which has unique values, or sorted sets where you can rank the set elements. These are the only standard data types that it supports. They recently added streams, which makes these lists persistent for messages. Okay, let me show some demonstrations just to show you. I picked Python, like I said earlier, for the notebook where I can run the code here. So this one is, just a second, let me clear. So yeah. So here what I'm doing is I'm connecting to a Redis that I'm running locally. By the way, I'm on a Windows machine. Redis is written on Unix for Linux, typically Linux or deployment. So I'm running on Docker on Linux on Windows host. So here I'm setting a value, a string value, and then reading it, and then printing it. Okay. Yeah, so if I do this, foo key is set to bar, and I'm reading foo back, not a big deal. But it can also store binary values. Here I'm reading an image, setting the image, and then getting it back and showing it. Okay, so this is able to write binary image. So this can store up to like 0.5 gig of binary data for each key. The other cool thing it has is expiry. You know, when you set the value, you can make it expire. Here I'm for 2 seconds. So if the value exists, I want it to expire in 2 seconds. And then, so here I'm setting the expiry, and then I'm reading it right away. So it gets the value, no issues. Now, if 2 seconds have passed, I hope it is. And then if I get it now, the data is gone. So you don't have the stale data sitting in memory, so it can clear it for you, which is nice. And we, by the way, we use this quite a lot because we have users coming in and going out, and we have their stale tokens that we don't want to sit. The other thing is like a linked list where you can use it, for example, for a news feed where I can just push it into a list, a sequence of values. Now, this works both as a queue or as a stack. So if you look at like in Java, you have deck. So it is like that, where you can add or remove from either side. So it's a, you can read it and then you can empty that list. Now, the other thing is you can also use it as a blocking queue where now what it is doing here is there are no elements now in that list, but I can make it wait for an element to appear. So this could be interesting for some use cases where you're waiting for, say, a participant to show up, and then when it does, you want to show that, right? So here I'm running it now. So this thing is running, okay? But there are no values in the list, so it's going to sit and wait. I'm just going to move to a fancy editor where I'm going to push a value to this list, something, okay. So I just pushed it there and then it came back here. So you can have a client block and wait for a value to show up, okay. The other thing is it can do sets where here I am having a set of friends and family, and I can do things like who is in both friends list and the family list, and who is in the union of friends and family. So you can do things like sets, which can be pretty handy when you're dealing with unique elements that you want to track. Similarly, you can use sorted sets where you can give a score. This can be used for online games, for example, where you have users and their scores. And then you can say, I want to pick the top 2 users, and then it'll give it to you pretty quickly. So these operations are like order 1 because it's not like scanning through the list. It's when you add these elements with the score, it's going to sort it right there. And then when you pull it, it comes back with the elements. It can do hashes. So for example, I'm contrived an example of a conference rooms where you have the room names and how many people it will allow. So I'm just setting up a conference room with all the different rooms. And then as you sign up and then use up the room, you can decrement it, and then you can see that some rooms are gone. So you could use it for cases like that. So hashes is the other thing. So I won't go on further. So these are like the building blocks for building applications. Now, the other interesting thing it has is probabilistic data structures. Now, a little bit on this. When you talk about data structures, you're talking about what you put in and what you take out. Normally, it's a one-to-one. You get what you put in. With probabilistic data structures, it's a little bit different. The output can be somewhat different from what you put in. It has its own interesting applications. One very, very common use is hyperlog. What it is a cardinality or count of unique values. I wanted to set up this demo, but I didn't get a chance to show that. So typically, if you're going to put unique values and count how many times some unique values have been added, if you use a set which stores unique values, you can see that it uses one item per unique value, right? And then the count. Whereas with hyperlog, it uses much less memory. So you can see an order of magnitude reduction in memory use. So it's very efficient by compacting what you add and storing it very limited amount of memory. Okay. How it does that is it does bit packing while putting that in, and it does it very efficiently. So this is very useful for when you want to show counts. For example, when you use Reddit, and if you want to see how many views a particular posting had. They use hyperlog to compute that. So this is one use case. The other probabilistic data structures are like you want to find the top k elements or Bloom filter. Bloom filter is when you want to get a definitely no, maybe yes kind of answer. Okay. This could be useful in cases whether, when you want to see if a particular IP address is present, you want to rule out that something which is blacklisted is not present. Yeah, you could use Bloom filter. Again, this is very efficient for both in memory consumption as well as performance. A variation of that is cuckoo filter, which Redis supports. That is more efficient in some scenarios. So I'm not going to go into that, but you can get these modules. And besides the basic data structure and some of these features, it also has extensions through modules. And there are a lot of interesting stuff that has been done by others, including from Redis Labs, which provides, for example, full text, much like Elasticsearch. You can put in documents and search over them. It builds a reverse index where you can search for terms. Similarly, you can use Redis Graph as a module where you have like friends of friends of friends kind of queries that it does using cipher-based querying language. This is standard in the graph databases. So it uses a standard querying language for doing graph searches. It supports JSON, there is time series, then there is gears where when you put in the data, you can make it do certain things. Like when you have triggers in Oracle or relational databases where you make it act when incoming data comes in. Here you can have a pretty complex sequence of actions, including publishing notifications for other applications to react. So this is a pretty interesting module. Besides this, there are modules for AI, neural networks, and SQL support, and so on. There are multiple other modules that it supports. And if you are curious to try it, it's pretty simple to install and try. So you get a binary if you're on Linux or Mac, or you can run it on Docker if you're on Windows. I have a Windows 10 with Linux WSL, that is Windows subsystem for Linux that comes with Windows. I installed that and I ran it. I pulled a Docker image and ran it on Docker. So all this code that is working is on Docker image. Redis is also available on AWS, Azure, Google Cloud. So you can use it there, or you can use even Redis Labs where they have a up to 30 MB free version that you can use. Yeah, so this is a pretty high level, quick overview meant for a lightning talk. Yeah, I hope if there are any questions, please let me know.